Let's sort a list of numbers from smallest to largest. Here we have 5, 1, 4, 2, and 8. We want them to come out as 1, 2, 4, 5, 8. Bubble sort is the gentlest way to get there. We only ever look at two neighbors at a time and ask a single question. Are these two in the wrong order? Here is the idea. We walk from left to right and compare each number with the one just after it. If the left number is bigger, they are out of order, so we swap them. Because we keep pushing bigger numbers to the right, the very largest value slowly bubbles all the way to the end in one pass. That is the invariant that makes this work. After the first pass, the last spot is correct. After the second pass, the last two spots are correct. And so on until the whole list is sorted. We take the length of the list. The outer loop counts the passes. The inner loop walks over the pairs that are not settled yet, and each time the left value is bigger than its right neighbor, we swap them. Notice the inner loop shrinks by index I each pass, because the tail is already in place. When every pass is done, the list is sorted and we return it. Now let's build it live, one block at a time, and watch the numbers fall into place. The function, the length of the list, and an outer loop that runs one pass for each element. The inner loop compares each pair of neighbors and swaps them whenever the left one is bigger. Once all the passes are finished, the list is in order, so we return it. Now let's test it and hit run. And there it is. 5, 1, 4, 2, 8 comes out as 1, 2, 4, 5, 8. Try shuffling the numbers yourself and watch them sort. Here is the whole shape. For each pass, we walk the pairs. If a pair is out of order, we swap. Otherwise, we move on. When the pass ends, if there are still passes left, we start another one. And when none remain, the list is sorted. How costly is this? We do about n passes, and each pass looks at up to n pairs, so the work grows like n times n. That is order n squared time. We only swap values inside the same list, so we use no extra space worth counting, order one space. 3 things to remember. First, the inner loop must stop one short of the end, because we look at index j and the one after it. Second, the sorted tail grows each pass, so the inner loop can get shorter and shorter. And third, a nice trick. If a full pass makes no swaps at all, the list is already sorted and you can stop early.